Hello, 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 hello. Good morning, good afternoon, good evening, my dear students. This is your one and only lovely AG sir, and I welcome all of you at our Shivai Academy. Today we are going to study string. What is string? Everyone is aware of what is a string. So in string we have force, and that force is known as tension force, and this tension is denoted by T. Okay, it is denoted as T. The force is tension and denoted as T. And strings are massless and inextensible until and unless it is said that it has some mass. You will consider it as a massless. Okay, tension force. Tension force always acts along the length of string. It always acts along the length of string, and specifically इसको रेड कर देते हैं. Such a way that it tries to reduce the length of the string. Please keep in mind, it always acts along the length of the string and such a way that it always tries to reduce the length of the string. What does this mean? Let us see with an example. Here we have this is ceiling, string, the block of mass m. Okay, if I tries to draw the FBD, so FBD will look like this. This is the block, this is the block of mass m. One downward force acts, which is mg, and another force is due to string, and this string will apply a force in this direction at this particular point, and at this point the string will apply a force in this direction. Means the upward force is T here, and for this upper point, if we zoom it out, we may find this that the tension acts in this direction. So in the string at lower point, tension is in this direction, which means this point force is acting, this tension force is acting such a way that the length of the string reduces. At this point the tension force is in this direction, means the force is acting such a way that length of the string is decreasing. Okay, let us try with a few more examples. Ceiling, string, block mass m, and this m is of 20 kg. Here m is equals to 20 kg. So forces, we will show it by red marker, mg, and tension. So for this particular portion, two forces are acting on the block. One is mg, another is tension, and as we can see the block is in equilibrium. We can write T is equals to mg is equals to 200 Newton. T is equals to 200 Newton acts vertically upward, and mg equals to again 200 Newton acts vertically downward. Am I clear? Very elementary question. Then after that, let us see this. Very easy question. This is wall, basement or ground, we can say, and string is attached to wall, ground, block of mass 20 kg. Now let us draw the FBD. The forces acting on the block, mg, normal, and the tension. Okay, here again we can see equilibrium. As there is equilibrium, we can write mg is equals to N is equals to 200 Newton, 200 Newton direction of mg is vertically upward, direction of normal is vertically downward, and again tension is also there. And as we all know that the block is in equilibrium, the tension, block is in equilibrium, so tension T will be 0. Why? Because there is no other force to overcome it. There is no other force. Why? Because there is no other force to overcome it. So the tension is 0. Tension is 0. Mg is 200 Newton. Normal is 200 Newton. Mg is vertically upward and the normal force is vertically downward. Okay. After that, this question. Again, very easy. Not to bother about anything. The question is like, let me draw it over here. Again a wall, ground, block, string, block of 20 kg, string is here, and external force is applied, F is equals to 20 Newton. Okay, this is the question. So again drawing the FBD. First of all, mg will act vertically downward, normal will act vertically upward. This will be tension, this will be force. Okay, now let us simplify. Again it is in equilibrium. As it is in equilibrium, we can write right equals to left and up equals to down. Upward force equals to downward force. Upward is N is equals to mg is equals to 20 into 10, which comes out as a 200 Newton. Normal is in upward direction, mg is in vertically downward direction. Right side force is tension, left side is F, and F is 10 Newton. This is all. Okay. Next, after that, bit difficult. Again it is easy, but bit difficult. Understand what I say here? 20 kg block, 20 kg block, string, wall, flare, and the force is acting in this direction. The magnitude of force is 10 root 2 Newton, 10 root 2 Newton, and the angle is 45 degrees. So first of all, let us resolve the force. This is 10 root 2 45 10 Newton and 10 Newton. How this came as 10 Newton? This is 10 cos 45, 10 cos 45, this one, and this one is 10 sin 45, not 10 sin 45, 10 root 2 and a 10 root 2. Component of 10 root 2. Component of this 10 root 2 in this direction is 10 root 2 cos 45, and 10 root 2 in this direction is 10 root 2 sin 45, which comes out as a 10 Newton, So instead of writing 10 Newton in this direction, angle 45 degree from the horizontal, I am making it as a 10 Newton in vertical direction, okay, and 10 Newton in horizontal direction. mg is always acting, no doubt in that. Normal force is always acting, no doubt in that, and tension is also here. Again, as we can see, system is in equilibrium. Up equals to down and left equals to right. Up equals to down, left equals to right, and let us simplify. Upward force is 10 plus normal equals to mg. So normal equals to mg minus 10. M is 20, g is 10, so that is 200 minus 10, which comes out as a 190 Newton. Normal equals to and left equals to right means in left there is a 10 and the right is tension. So tension acts in a rightward direction and that is of 10 Newton, and normal force is of 190 Newton in vertically upward direction. Okay, so I think this was not difficult much, bit difficult, only bit, not a much. Okay, so again making the components of force, let me draw the question first. Ground, wall, ground, up and down, round and round, याद रहूं मैं तेरे साथ. Come on, this is string and the force is acting in this direction and the magnitude of force is 50 root 2 and the magnitude of force is 50 root 2. Not like that. Follow my lead. 50 root 2 and the angle is 45 degree. Okay, so first of all let us making the components of force. This is 50 root 2 and as we can see this is 45, this will be 90, so this is again 45. So to make 50 root 2 we need these two vectors. We need the first one in this direction and the another one in this direction. So this is 50 root 2 cos 45 and this is 50 root 2 sin 45, which comes out as a 50 Newton, which comes out as a 50 Newton. So instead of writing this 50 root 2 at angle 45 degree with horizontal, I will convert it in this is 50 Newton, this is 50 Newton, and resultant of this will be in this direction 50 root 2. Okay, so no doubt in that mg will act. Mg is definitely there. Normal is also there. This is tension, and again we can see the system is in equilibrium. We can write what we can write. We can write up equals to down, up equals to down, and left equals to right, left equals to right. Up is normal and down equals to mg plus 50. Mg is again 20 into 10, 200 plus 50. So normal will be 250 Newton. Normal is 250 Newtons. Okay, left equals to right. Left, my little mistake over here is tension is not in this direction, but the tension is in this direction. Okay, so the left equals to right. 50, left is 50, right is tension, so tension will be 50 Newton in rightward direction. Okay, am I clear? Next, this one, Ig, not so difficult. Not drawing the complete figure, but this much is sufficient. mg let me draw it again. This is the direction of mg, this will be the direction of normal, and this will be the direction of tension. Okay, finally the figure is good. So how to solve this? First of all, let us put let us put our xy coordinates over here. First of all, let us put our xy coordinates over here. Sorry for my bad figure, I didn't mean that, but I hope you can understand. I don't think I can draw it. I am drawing it over here. So this is the surface and this is the normal. Okay, this is the direction of normal, this is the direction of tension, and this is mg. Okay, this line is parallel to surface. This line is parallel to surface. And this line is perpendicular to surface. First of all, draw two lines, one parallel to surface and another one perpendicular to surface. Okay, now if you closely observe, this is the angle. This is the angle 30. This will be 90. This will be 60. And again this will be 30 because this is the surface and this line is perpendicular, so this is 30. So my question got much easier. mg cos 30, mg sin 30, tension and upward force normal. So this is up, down, left and right. Again, up equals to down and left equals to right. Up equals to down and left equals to right. So up is normal and down is mg cos 30. 20 tan root 3 by 2. So the normal will be 100 root 3 Newton. Okay, right equals to left means mg sin 30 equals to tension. M is 20, G is 10, sin 30 is 1 by 2 equals to tension, and tension is equals to 100 Newton. Getting my point? Not so difficult, much easier question. After that, okay, here comes the villain. Ha ha ha. 20 kg, mg will act always in this direction, always. mg, tension and normal. Again draw two lines. Not much good color choice. One, two. Tension is in this direction. Drawing the FBD. Tension is in this direction. This is the direction of mg. This will be theta, and theta is 45 degree. So this will be mg cos theta. This will be mg sin theta, and this will be normal. Okay. Again, figure is something like this: mg cos theta, mg sin theta, tension, normal, and 10 Newton in this direction. So we can write left equals to right and up equals to down. So writing that what? Up equals to down. So what is up? Up is normal, down is 20 into 10 into sin cos 45, angle is, if I am not wrong, 45. So this is 200 into 1 upon root 2. So answer is 100 root 2 Newton. And left equals to right. So left is mg sin theta plus 10 equals to tension, 20, 10 sin 45, 1 upon root 2 plus 100 equals to tension. So this is 200 upon root 2 plus 10 equals to tension is equals to 100 root 2 plus 10 Newton. Okay. Then this one, not so difficult. Let me explain you the figure first. This is a block of 20 kg which is connected by some string, held on a 37 degree incline, and from that incline at 53 degree 10 Newton force is acting. This angle is from here, 53 degrees from the incline. Okay, am I clear? So let us draw the figure first. Let us draw the figure first. Parallel to surface, perpendicular to surface, this will be the direction of mg, this will be the direction of mg. This is 37, so this will be mg cos 37. this will be mg sine 37. This will be the tension, and if you observe carefully, one force is acting over here, 10 Newton with 53-degree angle. So the component of 10 Newton will be in this direction, plus 10 cos 53-degree, and this will be 10 sine 53-degree. Okay, so this line is perpendicular and this line is parallel. So we are writing our common formula, up equals to down, and then we will write right equals to left. But before that, let us check, do we have gathered all the data? Mg is there, tension is there, and the external force is there. Okay, no other forces, mg, tension, external force. Up equals to 10 sine 53-degree equals to down. No, plus normal. Normal will also act in this direction. Please note that. So plus normal equals to mg cos 37 degrees. N is equals to mg. M means 20, g is 10, cos 37. Cos 37 will be 4 by 5 minus 10 sine 53 degrees. Sine 53 is 4 by 5. So 5 4 is 5 2 is 160 Newton minus 8 Newton. So our answer will be 152 newtons. So the normal will be, this is the answer of N. So normal will be of 152 newtons. Okay, right equals to left. So right is tension plus 10 cos 53 equals to left mg sine 37. So from here T is equals to 20 10 3 by 5 minus 10 3 by 5. 5 2 is 5 2 is. So answer will be 120 minus 6 Newton. So this will be 114 Newton. So tension is of 114 newtons. Okay, am I clear? So enough for today. The end. Thanks for watching. और हंसते रहिए, मुस्कुराते रहिए और देखते रहिए शिवा एकेडमी. Okay, thank you. See you in the next class.